It was supposed to be another quiet shift in orbit. A small crew aboard a monitoring platform was reviewing the cameras pointed at the thin blue edge of Earth's atmosphere, expecting nothing more than drifting clouds and the slow rise of dawn. But then a dark streak flashed across the screen, sharp and narrow like an arrow cutting through the void. It didn't glow like a satellite, and it didn't shimmer the way a modern spacecraft usually does. Instead, it looked scorched, wrapped in metal that seemed to have survived fire. The astronauts zoomed in, each frame revealing more questions than answers. Wings shaped for flight, a long fuselage, and a surface so dark it felt almost ancient. There was no signal code, no transponder ping, no trace in any active flight registry. They pushed the zoom to its final limit, and a set of letters emerged from the grainy image: United States Air Force. Beneath it, a name that should not have been anywhere near Space X-15. A rocket plane retired more than half a century ago, now appearing at an altitude reserved only for spacecraft. And in that instant, one question unsettled the entire cabin. Was this a simple glitch in history, or had a forgotten flight accidentally broken through the sky itself? To understand how a forgotten aircraft could ever reach the edge of space, we have to go back to the late 1950s, a time when the United States was gripped by a single fear: falling behind the Soviet Union. Every headline reminded Americans that the world had changed overnight when Sputnik crossed the sky, and suddenly speed and altitude were no longer goals for pilots, but national priorities. Out of that pressure came one of the boldest projects in aviation history, a joint effort between NASA, the United States Air Force, and the U.S. Navy. Its name was the North American X-15. It was not built to win a dogfight or carry weapons. It was built as a flying laboratory, a machine designed to answer questions no wind tunnel could solve. How fast can a human fly? How high can a winged aircraft go before the sky stops behaving like air? And what happens to a pilot's body when the world beneath them starts to look like a curved blue line? The mission was simple on paper, but terrifying in reality. Engineers set targets that bordered on impossible. Mach 6, more than 6 times the speed of sound, over 300,000 feet of altitude, far above where fighter jets could reach, and temperatures so extreme that ordinary metals would melt. No one knew if a man could control an aircraft moving that fast, or if the wings would rip away the moment the air turned thin. Some engineers even wondered whether a plane could transition into the conditions of space and still fly like an airplane on the way back. These questions were not academic. They were test or die challenges, because the X-15 had no room for hesitation. Every flight pushed against physics, and the smallest miscalculation in angle, heat, or control could lead to disaster. The pilots who volunteered knew exactly what they were stepping into. There were no guarantees, no ejection at hypersonic speed, no safety net when the sky turned black. And still, they climbed into the cockpit, strapped into a rocket with wings, and prepared to fire it beyond every known limit. Each time the X-15 was launched from the wing of a B-52, the world held its breath. Would it break the next barrier or break apart under the pressure? Because in those years, the line between progress and catastrophe was razor thin. Yet without these dangerous flights, without these daring questions, the dream of entering space with a reusable winged vehicle might never have been possible. And among all those missions, 2 flights in particular would change everything, not just for the program, but for the history of human spaceflight itself. To understand why the X-15 could appear in a place no airplane should ever reach, we need to look at its shape, because everything about this machine was built for one purpose: to go faster and climb higher than anything with wings had ever done. The aircraft stretched roughly 50 feet from nose to tail, a narrow black spear weighing more than 15 tons. It did not look sleek in the traditional sense. It looked purposeful, like a steel projectile shaped by fire. Its matte black skin was not a style choice, but a necessity, because at hypersonic speed, the air around it heated the metal until it glowed. Engineers painted it with a special coating that could survive temperatures that would destroy a normal jet. Its wings were tiny, almost comically small for a plane of its size, because wings create drag, and drag was the enemy. The X-15 did not need graceful lift. It needed stability while slicing through air so thin that flight barely existed. At the tail, instead of a broad rudder, the plane carried a tall wedge-shaped fin, a design meant to keep it steady when the atmosphere thinned and the sky darkened into space. And at the heart of this strange machine was the XLR-99, one of the most powerful rocket engines ever mounted on a manned vehicle. It burned an explosive mix of anhydrous ammonia and liquid oxygen, and when it ignited, it could consume thousands of pounds of propellant in less than 90 seconds. Those 90 seconds were enough to push the aircraft past Mach 5, Mach 6, sometimes even faster, leaving the world behind in a blur. But the most surprising feature of the X-15 came into play when the air became too thin for wings or rudders to matter. Above a certain altitude, traditional controls stopped working, so the engineers installed small peroxide thrusters on the nose and wingtips. In those moments, the X-15 stopped behaving like an airplane and began acting like a spacecraft, rolling and pitching through reaction control jets just as later astronauts would do in orbit. That is why many historians describe the X-15 as the first draft of the spaceplane, an early sketch of the technology that would eventually evolve into the space shuttle and every reusable vehicle that came after it. Yet there was an irony hidden in its design. The aircraft was built to push the edge of the sky, not to cross into space itself. On paper, it was a research plane. In practice, its shape, its engine, and its control systems hinted at something far more ambitious. From the very first blueprint, the X-15 carried the potential to climb higher than anyone admitted. It was designed to touch the boundary of space long before anyone believed a winged craft could actually reach it. The X-15 did not leap into the unknown on its first day. It began with quiet, almost modest flights in 1959, when the aircraft was carried under the wing of a B-52 and released without firing its engine. These early missions were silent glides, meant only to test how the strange black rocket plane handled the air. Pilots learned how it rolled, how it pitched, how it behaved when nothing but gravity was in control. Once those answers were clear, the real flying began. The rocket ignited, and the X-15 stopped being a research tool and became a weapon of speed. Each launch carried the plane higher and faster, and for the first time, American pilots found themselves climbing toward altitudes no jet had ever touched. In those early runs, something remarkable happened. Several pilots broke the American definition of space, the 50-mile mark recognized by the United States as the boundary where Earth ends and space begins. They were no longer just test pilots. They were astronauts in everything except the title. One of them was Robert M. White, who pushed the aircraft to an astonishing 314,750 feet, roughly 59 miles above Earth. The United States Air Force awarded him astronaut wings, officially marking him as someone who had crossed into the realm where the sky fades into black. Another pilot who sat in the X-15's cockpit was a young test pilot named Neil Armstrong. Before he ever touched the lunar surface, before he said a single word that would echo through history, he flew the X-15 7 times. The aircraft taught him what it felt like when the horizon curved and when the sky turned dark at midday. It prepared him for the silence of space long before NASA selected him for Apollo. As the program advanced, more records fell, more boundaries shifted, but there was one line no one had crossed. The American standard of 50 miles was impressive, yet the international governing body for air and space, the Fédération Aéronautique Internationale, used a different boundary, 100 kilometers, or about 62 miles, the Kármán line. According to the world, that was the edge of space, and despite dozens of flights, despite near-perfect trajectories, despite brushing the ceiling of the atmosphere again and again, no X-15 pilot had officially crossed it. Distance was not the problem. The aircraft had the power. The flights had momentum, but the line sat just beyond reach, like a glass ceiling the program was not yet ready to break. The gap between 95 kilometers and 100 was painfully small, just a handful of seconds in full burn. Yet for years, that tiny margin stood untouched, as if an invisible barrier waited at the edge of the sky, daring someone brave enough to cross it. Among the many pilots who sat inside the X-15, one name stood apart when the program reached its most ambitious stage: Joseph A. Walker. He was not a wide-eyed newcomer chasing glory. Walker had already flown combat missions for the United States Air Force, mastered high-risk test aircraft, and later became one of NASA's most trusted research pilots. By the time he joined the X-15 program, he had built a reputation for a calm mind under pressure, the kind of focus needed when the margin for error was measured in milliseconds. Walker's experience was unique. He understood high-altitude aerodynamics better than most engineers. He knew the strange physics that ruled the sky above 200,000 feet, where the aircraft no longer behaved like a plane, yet had not fully become a spacecraft. He had flown gliders, jets, rocket craft, and atmospheric test vehicles, and each skill layered into a profile that NASA valued above all. A pilot who could think clearly when the world outside the window no longer looked familiar. That was why, when the program prepared to attempt something no human had achieved in an aircraft with wings, Walker was the obvious choice. Missions were divided carefully, and Flight 90 was designed as the first true push toward the international definition of space. NASA mapped out every phase: launch from the B-52, ignition timing, pitch angle, climb arc, and engine cutoff. The goal was straightforward but historic. The flight had to reach 100 kilometers, the Kármán line recognized by the Fédération Aéronautique Internationale, and do so without putting the aircraft or pilot in unnecessary danger. It would be a clean, controlled ascent, a demonstration of precision rather than brute force. Walker's calm discipline made him ideal for that plan. He followed profiles exactly, wasted no motion, and understood how to ride the narrow corridor between aerodynamic control and orbital-like flight. The engineers trusted him because he never pushed harder than the data allowed. Yet they were preparing to send him into a zone where the data itself began to thin out. Everything about Flight 90 was calculated with intense scrutiny. The trajectory was modeled repeatedly. The thermal loads were estimated with every known equation. The reaction control thrusters were checked until the technicians could recite the readings from memory. The mission had margins, backup plans, and strict thresholds for abort. On paper, it was the safest attempt at the highest altitude the program had ever planned. But there was one factor: no simulation fully captured. The XLR-99 engine was powerful, and its burn time determined everything: altitude, speed, stress, and atmospheric exit. The plan assumed a precise cutoff. Reality would prove different. The one variable no one truly controlled was how long that engine would keep firing once the countdown reached zero, and that small uncertainty was about to push Joseph Walker far beyond the line he was assigned to reach. Flight 90 began the way every X-15 mission did, with the massive B-52 slicing through the thin air above Nevada and the rocket plane locked under its wing like a steel arrow waiting to be fired. Inside the cockpit, Joseph Walker ran through the checklist with the same steady tone he always used: his voice calm even as the world around him shrank into the high-altitude blue. At 45,000 feet, the launch command came. The X-15 dropped away from the bomber, falling for a moment in total silence, and then Walker hit the switch. The XLR-99 ignited with a force that slammed him back into the seat. From the ground, it looked like a star had exploded beneath the wing of the B-52. The plan was simple, an 83-second burn. That number had been repeated in every meeting, every simulation, every briefing. 83 seconds was enough to take the aircraft to the edge of space, but not past it. Anything longer risked overshooting the safe corridor. But on this day, the engine did not cut off at 83 seconds. It burned for 84.5. That single extra heartbeat changed everything. 1.5 seconds at full thrust pushed the nose up half a degree more than intended, and half a degree at hypersonic speed meant a trajectory that climbed tens of thousands of meters higher than the planned ceiling. The X-15 shot upward, accelerating through Mach 5, Mach 5.3, Mach 5.5, the sky outside darkening into a deep indigo as the air thinned and the planet curved below. Walker felt the aircraft transition out of aerodynamic flight. The wings no longer mattered. The control stick responded only through peroxide thrusters now, tiny pulses nudging a machine that had essentially become a spacecraft. When the climb finally slowed and gravity pulled against the rocket plane's momentum, the numbers stabilized. Altitude: 347,000 feet, 106 kilometers. He had crossed the Kármán line, the internationally recognized edge of space. The first civilian in history to do it. The first human to reach space in an aircraft with wings. For a few seconds, Joseph Walker floated in a region no pilot before him had ever touched, looking down at Earth's horizon glowing sharply against the black. And what made the achievement even more surreal was its cause. Not a redesigned engine, not a new flight profile, not an intentional leap into the unknown, just one detail no one accounted for. An engine burn that lasted longer than a single breath. 1.5 seconds, and the X-15 left the sky behind. After Flight 90 shattered every expectation, NASA refused to dismiss the result as a lucky accident. The data looked real. The trajectory looked clean. The altitude crossed the line with undeniable precision. But for engineers, one extraordinary event was never enough. They needed confirmation, a second ascent that would prove the X-15's ability to climb beyond the atmosphere wasn't a mathematical fluke. That confirmation would come from the same pilot who had already rewritten the limits of flight. Joseph A. Walker was assigned to fly again, this time under even tighter measurement protocols. On August 22, 1963, the B-52 released the X-15 over the desert, and Walker began the mission that would become the defining moment of the entire program. The engine lit with its familiar roar, hammering the aircraft forward with a violent burst of power. Almost immediately, the X-15 was pushing through Mach 5, climbing along a needle-thin corridor where the slightest drift could ruin the flight. Walker held the line. He knew the feel of the aircraft at the edge of the atmosphere, knew the strange balance between aerodynamic lift and reaction jets, and he guided the craft into the same transition zone where Flight 90 had made history. As the burn ended and the climb continued, the sky around him darkened to a deep velvet black. When the numbers settled, the altitude reading confirmed what few had believed possible for a winged vehicle. Altitude: 354,200 feet, 108 kilometers, higher than any airplane before it, higher than any airplane since, a record that still stands today. At that height, the world below was no longer a landscape but a sphere. Walker could see the curvature of Earth stretching across the horizon, a blue arc surrounded by darkness. For nearly 5 minutes, the aircraft drifted in weightlessness behaving less like a plane and more like an early space capsule. Every movement required gentle bursts from the peroxide thrusters. The cockpit was silent except for the hiss of the suit's airflow and the faint click of the guidance system. It was a moment of calm inside a mission built from precision and danger, a moment when Walker experienced the same physical sensations that astronauts in orbit would later describe. And then the twist that sealed his place in history. Joseph A. Walker became the first human to enter space twice without ever riding a vertical launch rocket. No massive booster, no tower countdown, no capsule atop a pillar of fire. Just a black aircraft with small wings, a powerful engine, and a pilot whose skill carried it past the end of the sky not once, but twice. With Flight 91, the X-15 was no longer just an experimental plane. It was unmistakably a spacecraft in disguise. For all its triumphs, the X-15 program carried a shadow that no engineer or pilot could ignore. Pushing the boundaries of speed and altitude always meant flirting with danger, and in 1967, that danger finally struck. On November 15th, NASA test pilot Michael J. Adams took the X-15 on Flight 191, a mission designed to study high-altitude behavior much like the ones Walker had flown. Adams was an Air Force officer, disciplined, calm, and determined, but even the most skilled pilot was vulnerable to the razor-thin margins of hypersonic flight. During the ascent, his aircraft climbed more than 50 miles high, but as it entered the long arc back toward Earth, a series of technical issues began to compound. A guidance malfunction fed incorrect readings into the control system. The aircraft rolled into a spin. At that altitude, with air too thin for conventional control surfaces, the X-15 became almost impossible to recover. In the final seconds, the aircraft dropped into denser air at extreme speed, and the stress shattered the airframe. The X-15 broke apart high above the Mojave Desert, falling in fragments across the sand. Michael J. Adams did not survive. He was later awarded astronaut wings, marking him as someone who had crossed into space, but the honor came with a weight that the program would carry forever. The loss shook NASA, the Air Force, and the entire flight test community. It forced engineers to confront how narrow the safety margins truly were, how even a small error in a craft flying at thousands of miles per hour could escalate beyond recovery. Though the X-15 had completed 199 flights by the time the program ended in 1968, Flight 191 remained a solemn reminder that every breakthrough carried a cost. When the program finally shut down, it left behind achievements that seemed too large to fade. The first civilian in space, the highest altitude ever reached by a winged aircraft, data that shaped the Apollo command module, insights that fed directly into the space shuttle's design, and the foundation for reusable spacecraft that define modern flight. Yet as the space race accelerated, the spotlight shifted to Saturn rockets, lunar missions, and the spectacle of astronauts walking on the moon. The X-15, once the fastest and highest-flying plane on Earth, slowly slipped from public memory. And the twist history rarely mentions is that the aircraft which first proved humans could fly to space without a traditional rocket became one of the great unsung heroes of the space age. In the end, we return to that impossible moment in orbit when a group of astronauts stared at a dark silhouette slicing beneath their station, a shape that looked more like a ghost of the past than a living aircraft. The letters on its side told the truth. They were looking at the same machine that once broke the sky open. The X-15 did not accidentally stumble into space. It was built on ambitions so extreme that even the people who designed it could not fully imagine the heights it would reach. Decades later, its legacy echoes through every winged spacecraft that followed. The Space Shuttle carried its guidance ideas. Modern experimental planes carry its data on heat and control. Test pilots still study its flights to understand how machines behave when the atmosphere gives way to vacuum. What the X-15 proved, more clearly than any rocket of its era, was that a plane with wings could slip across the boundary of Earth and return again on its own terms. And it did this long before the world was ready to believe it. That is why the sight of it drifting near the edge of space feels less like a mystery and more like a reminder of what humans dared to attempt when fear and limits meant nothing. So now the question belongs to you. Which part of the X-15 is truly the most terrifying? Its speed, its altitude, or the fact that it crossed into space before anyone fully understood what it had achieved? Share your thoughts below and subscribe to MindGap to uncover more secrets history tried to hide.